Hello and welcome to today's video where we shall be discussing integration of rational/algebraic functions. So let us start. So we say let f of x equal to ax raised to the power n, where a is a constant and n is any number that is not what? N is not equal to negative what? 1. So n can be any number except minus 1. In a short while, we shall explain to you, we shall show you why n should not be minus 1. Then we are saying that if we integrate this function f of x with respect to x, that means we are integrating the function f of x is this, the function ax raised to the power n with respect to x. Now what the rule says is this: we shall add 1 to the power of the function. So we have ax, we increase the power by 1 to n plus 1 and divide also by n plus 1 plus c, where c is our constant of what? Integration. In our first video on integration, I had explained to you why we add the constant word c. So you check the description box below and where we shall refer you to the first lecture on integration. So when we integrate a polynomial function or algebraic function, this is what happens. This is a rule. Now we had said here that n should not be minus 1. Now look at this. If n is minus 1, the function below here becomes what? This becomes minus 1 plus 1. This is equal to what? 0. So what we now have would have been ax raised to the power n plus 1 divided by what? 0. And we know that division by 0 in mathematics is not allowed. That is why we say that for any algebraic function or a rational function or a polynomial function, as the case may be, that the value of n must not be what? Minus 1. So we shall take a couple of examples now to demonstrate further how we apply this rule in integrating polynomial functions as well as algebraic what? Functions. For the first example, we wish to integrate the function 4x squared dx. So this will give us what? So by this rule we've just explained, the power here is 2. So n is equal to 2 here. So we have 4x. We increase 2 by 1. So we say 2 plus 1. Divide by what? 2 plus 1. Once we have done this, we have integrated. And we must add what? The value c, which is what? The constant of integration. And I also explained in the last video that this constant is only added for indefinite integrals. That means integrals that do not have limits. There are no values here and here. Okay, so if we simplify this further, what do we get? We get 4x, 2 plus 1 is what? Is 3, divided by what? 3, plus the constant of integration c. The next one says we should integrate 5 dx. Integrate the constant 5 with respect to x. So what do we do? Now in this function, we see that 5 is just a constant. There is no x. So let's assume that we have integral of 5x raised to the power 0. This is the same thing as 1. So there's no difference with this with respect to what? Respect to x. So what will this become? If we integrate this, we will get 5 by the same rule, x. We increase the power of x by 1. So 0 plus 1 divided by what? 0 plus 1 plus our constant of integration, what? C. So this will give us 5x, 0 plus 1 is 1, so that is 5x divided by what? 1 plus c. And that is nothing but what? 5x plus c. So when you integrate 5 dx, what do we get? We get 5x plus c. In a similar fashion, if we integrate 4 dx, what do we get? We get 4x plus c. If we integrate 10 dx, what do we get? We get 10x plus c. So what we did here was a simple trick. Since 5 has no x, we introduce x with power 0, which is the same thing as 5, and we arrive at 5x plus c. The next example, we should integrate 4x cubed plus 5x minus 3, all with respect to x. So what do we do? Just like we did before in differentiation, we integrate each term of this expression. So we're going to have, so that will give us the integral, the integral of the first term 4x cubed with respect to x plus the integral of the second term 5x with respect to x minus the integral of the third term 3 with respect to x. So if we apply that rule, because these are all polynomials, we have 4x, the power here is 3. So we increase 3 by 1, so 3 plus 1, divide by what? 3 plus 1. Plus, for the second function, we have 5x, the power here is 1, so 1 plus 1, divide by what? 1 plus 1. Minus 3. If you recall in the last example, when we integrated 5, what did we get? We got 5x. So this will give us 3x plus c, the constant of integration. Now you observe here also that though we have 3 terms, 1, 2, 3, we only have one constant of integration. So it doesn't matter how many terms you have in your expression. Once you integrate, you only have one constant of what? Integration. If we tidy it up one more time, we have 4x, 3 plus 1 is 4, divided by 4, plus 5x squared over 2 minus 3x plus c. And here this 4 can knock this 4 off, and we have x to the power 4 plus 5 over 2x squared minus 3x plus c. And that's the value of our integral. For the next example, we have to integrate the function 2 divided by x to the power 4 dx. So very quickly, this function, we can rewrite it as the integral of 2x to the power minus what? 4 with respect to x. So this way it becomes easier to apply the rule. So here our n is what? Negative 4. Remember, we said that our n could be any number except what? Minus 1. Good. If we apply the rule we've just learned, what do we get? We get 2x minus 4 plus 1. We increase it by 1. Divide by minus 4 plus 1. Divide by minus 4 plus 1. And once we have done that, we have integrated. We now introduce our constant of integration, c. If we tidy it up one more time, we have 2x minus 4 plus 1 is minus 3. Divided by what? Minus 3 plus c. And that is the answer. If you like, you can just tidy it up one more time. It's no problem. Let's just do it. We have, this will give us negative 2 over 3 x to the power 3 by indices. And this becomes 1 over x cubed. This is it. And then this is minus 2 over 3 x cubed. And that is the answer. Plus, of course, our constant of integration, what? C. The next example, we wish to integrate the square root of x with respect to x. Okay. What is n here? The value of n is not obvious unless we write it as the integral of x to the power what? 1 over 2 with respect to x. Because by indices, the square root of x is nothing but what? X to the power 1 over 2. Here our n again is 1 over 2. So we can apply the rule that says x to the power 1 over 2 plus 1 divided by 1 over 2 again plus 1. Of course, was a constant of integration, c. So if we add 1 over 2 plus 1 over 2, what do we get? We get 3 over 2. So that gives us x to the power what? 3 over 2 divided by what? 3 over 2 plus c. Of course, if we tie it up one more time, this just gives us 2 over 3 x to the power what? 3 over 2 plus c. So the trick here is we had a square root, a radical. And to apply the rule we have just learned, we change the square root, into what? A power. Because this method works really when x has just a power. And for polynomial functions, and as well as what? Algebraic functions, like in this case. Okay, so in this method of integration, we don't involve sine, we don't involve cosine, we don't involve tangent, we don't involve exponential and the rest. Just strictly polynomial functions as well as what? Algebraic what? Functions. So let us take our very last example for this section. So we have here the integral of 2 divided by the cube root of x dx. Now to apply the rule we've just learned for polynomial functions, we have to express x in terms of its powers, right? Okay, so this will give us the integral of 2 divided by, now the cube root of x simply means x raised to the power 1 over 3. Just like in the previous example, the square root of x meant x raised to the power 1 over 2. So with respect to x. So we can also do this again here. We can say integral of 2. We take this x, up. We have x raised to the power negative 1 over 3 dx. So this way our n is now what? Minus 1 over 3. So if we apply the rule we've learned, this will give us 2x minus 1 over 3. What do we do? Plus 1. Divide by the same power, minus 1 over 3 plus 1. And once you are done integrating, you must say plus c. You must add your constant of integration. So what do we now do? We tidy up. So negative 1 over 3 plus 1 gives us what? Gives us 2 over 3. So that gives us 2x raised to the power what? 2 over 3 divided by 2 over 3 plus c. You can go ahead and tidy it up one more time. And this gives us 3 times 2. That is 6x 2 over 3 divided by what? 2 plus c. And that is nothing but 3x raised to the power 2 over 3 plus c. You can pause the video and see that if you tidy this up, you get nothing but 3x raised to the power 2 over 3. So we have just shown how we carry out integration that involves polynomial as well as what? Algebraic functions, even rational functions. Now in our next video, we shall go a little bit further to look at how the techniques we employ to integrate functions that involve trigonometric, or rather what you say, trigonometric functions. So before then, like this video, make comments, and please subscribe to this YouTube channel. Bye.